everyone, welcome to Vedantu English. I am Diksha Kaushal, your chemistry master teacher. So everyone, we are preparing for VITEEE right? One of the best universities of India, and because it has its own exam, right? So there is another chance, especially for those students, right, who are thinking that maybe not, I don't know if I'll get admission from my JEE means marks or not. Then this is your second chance, guys, and take this very seriously. Don't delay this, because this is a very good university with great amount of packages that you will get once you get placed from here, right? So have complete focus for the next 15 days on VITEEE, and I'll be taking other exams as well. So you just need to tell me what are the exams that you are doing, right? So maths and physics is currently in processing. Don't worry, just an update on that, right? So I have talked to the teachers and they are saying that okay, we are like we can take time, right? It's just that final, it's a big process. It's not easy to take class on someone else's channel. So right now it is still in the processing, but just comment as I am saying that I am showing all these proofs to the teachers and the teams, right? That to the managers as well, that okay, students are in demand of that and they need it, right? So from your demand, Vedantu will definitely fulfill, right? So that is why I'm saying, like, demand from us so that we can give you that thing, right? If you don't know you need it, then how can we provide it to you, right? Okay, so let's start with the class, right? Okay, yes everybody, let's start with the class without wasting any time. So we have 30 questions of inorganic chemistry, and this is the day 1 of VITEEE. We have just started it and we'll tell you every single thing about it, but before that, chemistry I am starting section by section, right? So that you can understand what is the difference in JEE mains and VITEEE. And yesterday I have taken top important topics of physics, chemistry, math, right, for VITEEE. You can go and check that out, right? That is a very important video for all of you. If you're thinking, if you're done preparation for JEE mains and you're thinking what extra to study in VITEEE, that is the video for you. So now let's start it without wasting any time. And guys, these are all the PYQs, and I'll be focusing on PYQs because PYQs are repeated. Even JEE mains questions are as it is repeated in VITEEE, and its own PYQs, similar kind of questions are repeated. So for that, you need to know what is the pattern of VITEEE. So only the PYQs I am picking up here. Let's start with the first question of inorganic chemistry, that is, among the following the molecules having same bond order. Now when I talk about bond order here, same bond order, now this clearly we can see that this corresponds to molecular orbital theory, and molecular orbital theory has a very simple trick based question here, that I'll just write it here. The trick is that for 14 electrons the bond order is 3. As you go 14, 15, 16, 17, 18, and here as you go 13, 12, 11 and 10, what you will see, there is decrement of 0.5 here. This is 2.5, this is also 2.5, this is 2, this is 2, this is 1.5, this is 1.5, this is 1, this is 1, that is a bond order here, right? So to calculate the bond order, firstly we need to understand how many electrons are there. So carbon has 6 electrons and oxygen has 8, 7 into 2, 14 electrons in total, right? This oxygen O2 has 16 electrons, 1 oxygen 8 into 2, 16. Plus 2 for this negative, 16 plus 2 is 18 here, right? Then O2 negative, 16 plus 1 is 17. This is CO. Carbon is 6 plus 8, again it is 14 electron here. This is O2, that is 16 plus 2, that is 18 electrons. B2, hydrogen, helium, lithium, beryllium, boron. Boron is 5. 5 into 2 is 10 because 2 boron are there, right? Then carbonyl, CO, again we have discussed it. It is 14 electrons. And N2, nitrogen is 7. 7 into 2 is 14. Because of this positive charge, we will subtract 1 from it. So it will be 14 minus 1, that is 13. So you can see from here the bond order for 14 is going to be 3. right? So I'll just write the bond order here. Here bond order is going to be 3. Here for 18 it is 1. For 17 it is 1.5. For 14 it is again 3, and they are asking you having same bond order. So this does not have. 18 is 1 and 10 is also 1, that you can see. 14 is 3 and 13, what was that? 13 was 2.5 here, right? So you can clearly see this one wins over here. So answer is C. But still we'll see if there is anything else that they have mentioned here. Molecules having same bond order, that is written here, right? So answer is going to be C is the correct answer here. So mark it C as the correct answer here. That's it. That was your simple, without even using like MOT full-fledged configurations. We have just directly answered with the help of a direct trick here, right? So next question is, which actually inorganic chemistry will be the most scoring of all the other subjects here. If you see inorganic and English, right, within seconds you will be able to answer. So they are very scoring subjects, right? So which of the following has maximum dipole moment? Now see, for maximum dipole moment, the difference in electron negativity has to be maximum. If the difference in electronegativity is maximum, polarity will be more. That is why dipole moment will be more here, right? So if you see, nitrogen and chlorine both have the same electronegativity, that is 3. So here dipole moment is not maximum. Here it is, I think, 2.8. Here it is hydrogen is 1, nitrogen is 3, and hydrogen is 1. So here the electronegative difference is maximum. Here it is nitrogen and iodine. This is 3. I think this is 2. Bromine, iodine. Fluorine, chlorine, bromine, iodine. Iodine will have even less, yes. Okay, so this has like nitrogen and bromine here. This has 3. This has something 2.8. You don't even need to remember all of that. We know that hydrogen has electronegativity 1 and nitrogen has 3. Right? Hydrogen is very less electronegative. So that is my maximum difference in electronegativity will be here. That is why it will have maximum dipole moment. So answer is going to be NH3 is the correct answer. If you draw it here, it will be like this. This will be the lone pair. This is hydrogen. This is hydrogen. This is hydrogen. Here always the dipole moment goes from electronegative to less, to less, to less, and here atom to this. Right? So here, because of dipole, the mu is very high here. Even if you subtract atom to lone pair, even then it will be the highest. So answer will be C is the correct answer here. Right? Okay. Next question is, hydrogen bonding is maximum in which of the following? So tell me, everybody in the chat box. I can expect you. Yes, very good. Pauling scale. How to find there are so many scales of finding electronegativity, right? Mulliken scales, Pauling scales you have, but from the formula they don't ask you the question, okay? They ask you general factual based question like which of the following has highest electronegativity, order of electronegativity, these kind of things they ask you, not to calculate exact amount, okay? So hydrogen bonding, if you see, it is CH3, CH2, and this is OH. This is methoxymethane is CH3, OCH3. Chloroethane is CH3, CH2Cl, and this is NN diethyl aminoethane, right? So again here what you have, this is NN diethyl, like if you have NH3 here, right, one will be ethane, that is C2H5. NN diethyl means here also it is 3 times ethyl you have on nitrogen, right? So see, firstly see which of the following has highest electronegativity. Out of this it is F, then O, then N. Chlorine is not even there in the race, right? So it is eliminated. Then oxygen and nitrogen, nitrogen has less, so it is eliminated. You have oxygen here. So out of these two, we know that ether does not show hydrogen bonding. So many students feel that ether shows. But for hydrogen bonding, the condition is that hydrogen should be attached to electronegative element. Then it will form hydrogen bonding with another electronegative element. Here, this hydrogen is not attached to any electronegative element directly. That is why this will not show any hydrogen bonding here. So it will be ruled out. Answer will be A is the correct answer. That is, ethanol will give you hydrogen bonding. I can see this over here. Dhamu, then Lano, Vijay, Jode, Stone, easy, very good. So you are answering, that's awesome. Okay, now let's talk about the next question here. The next question is 2022 question. They say a colorless solid on heating evolved CO2. There is some colorless solid out of all these things. There is some solid which evolved CO2, right? Also gave a white residue soluble in water. Okay. Residue also gave CO2 when treated with dilute HCl. So out of this, following these conditions, there is this particular thing that is NaH. This is a very general question. We used to study this in even lower classes, that bicarbonates, when it reacts with the colorless sodium on heating, right? Wait a minute, what just happened? I just observed that I was not there only, right? NaHCO3, when you heat it, it gives you CO2, right? CO2 is evolved here, right? Also gave a white precipitates, that is CaCO2, right? No, not CaCO2, that will be NaHCO2, NaCO2, right? Then we are saying that when it is treated with, now this will be soluble. Now they are saying that this residue here, that is white, that when it is added in HCl also gives CO2, right? This is what they want to say. Yeah, blackout was there. I just realized it now only, right? Okay, tell me everybody, is that clear? Is that clear, everybody? Tell me, is that clear? So here answer is going to be NaHCO3 is the correct answer. NaHCO3 will give you Na2CO3 within HCl, which also gives CO2, right? So answer is going to be D is the correct answer here. Next question is based on the general properties here. So it is helium. Now helium has highest electron affinity, most electropositive, highest ionization enthalpy, strongest reducing. See, if I see, helium is actually having, like, it does not exist as He2. Helium twice does not exist. It has a very high ionization enthalpy because of noble gas. So that is why we can say A is 4 here. A is 4 in all the cases, so there is no problem. Then we have chlorine. It is not the most positive element. Chlorine is definitely not. Calcium can be the most electropositive element out of these four because this is a metal. So we can say C is 2, C is 2, C is 2, C is 2, C is 3 here, 3 here, C is 2 only here. So I can say A is the correct answer. B is 1. Chlorine is high electron affinity. Yes, among these chlorine has high electron affinity. Now we have studied it in that fluorine, chlorine, bromine, iodine, right? Down the group, electron affinity should decrease, but actually it is the opposite. Chlorine has more electron affinity as compared to fluorine because fluorine is very small in size, right? So that is why out of these elements, definitely chlorine has highest electron affinity, right? So this is one. And then lithium is strongest reducing agent that you have also studied in electrochemistry. Fluorine is strongest oxidizing agent. Lithium is strongest reducing agent, right? So here answer will be D is C. So answer is A is the correct answer that I can see from here, right? Because these are your previous year question only, right? I am not making them up. Trust me, I have not made this question. You can see the PYQ. It is there in your last year questions only, last year, right? So they are asking these kind of questions only in VITEEE. It is definitely easier than JEE Mains, right? That is why the competition also, you have to see one more thing, that competition is also high. Students wants to crack this exam. So you have to like be fully efficient without any negative marking, you have to score good here, right? Which of the following order in respect to ionization, with respect to ionization therapy is correct here? Now it is lithium, like okay, so you can also write it as boron, carbon, nitrogen, oxygen, fluorine. So what exactly should happen talking about ionization enthalpy? Along the period, ionization enthalpy should increase in general. So that means it should be like this. But here, if I talk about NOF, it should be like this. But in reality, because nitrogen has 2s2, 2p3, that means it has half-filled configuration. It has half-filled configuration, and that is the reason, because of its half-filled configuration, it is not able to have less ion. It is very difficult to lose electron because it is very stable. So that is why nitrogen will have more ionization enthalpy as compared to oxygen. Then fluorine will also have more. So here answer will be nitrogen has more, then oxygen, then fluorine. So answer is C is the correct answer here. Can I see that? Hey, can I see that? Oi, hoy, what is happening? What is happening? Why this OBS and everything is getting like mental breakdown is happening, right? Mental breakdown, guys. My camera is having mental breakdown. My camera is having mental breakdown. Like, oh my god, so much to remember. Exam are not completing only. Sometimes I am giving JEE main, sometimes I am giving this Diksha ma'am is not leaving me only. She is daily in the studio and teaching. Diksha ma'am, please go. Give me some rest. But I am like, no, I can't take rest. Camera, I can't give you rest. Listen, camera. Camera is in front. I'm not talking to you guys. I'm talking to the camera that is in front of me. Bro, please take a chill pill and let us study. Because you are thinking, camera is thinking, now JEE means is over. Now what I'll do, I'll relax. I am saying, I am coming daily here and teaching again and again. They're like, why Diksha ma'am? Why Diksha ma'am? I'm saying, bro, exams are still left. Wait 1 month. After that, I'll give you break. Isn't it? Okay. Chalo, now let's see. Which of the following is false regarding shielding effect? Right? Shielding effect means an effect where we say that outermost electron, here you have inner nucleus, right? And these outermost electrons, right? Someone is here nucleus, right? And these outermost electrons wants to attract this nucleus, but what is happening here? There are inner core electrons, that is the brother, the father, right? Like, you can't come near to our girl, right? So this boy is like, okay, I like her, but others are like, okay, go away. So same thing is happening. Shielding is happening, protection is happening. So the magnitude of screening depends upon number of outer electrons, not at all. Not at all. It does not depend upon the outer electrons. It depends upon the inner core electrons. Inner core electrons. So we got our answer. A is the false statement here. Arey yaar, what is happening, bro? Wait a minute, guys. Let me just wait a minute. I am
I am
also a
also
very
very
stubborn
stubborn
kind
kind
of
of
person.
person.
The
The
camera
camera
has
has
no
no
idea
idea
about it.
about it.
I am a very stubborn person. If I have decided to take the class, I will take it no matter what, right? So I am a very dheet person, right? So if I am here, it doesn't matter. I'll be teaching no matter this camera is showing tantrums. I don't care. Camera, we don't care. We'll study, right? Even if I have to. Now also it is echoing. Now it should not be echoing, guys. I'll just change the settings here a little bit. Now it should not be echoing, right? Okay. Is it now echoing? Hmm. Wait La 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 la. La 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 la. La 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 la. No, I'm not stuck. Now you tell me. I'm singing by the time. Na 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 na. Na 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 na. Done? Okay. So I'm just relaxing myself in between. Right? Okay. Chalo. Let's see. Which of the following is false? So in shielding effect, I'll just look at myself. If I get stuck in between, I'll see that. Okay. Don't worry. The magnitude of screening effect depends upon outermost electrons, not at all. It depends upon the inner core electrons. Then the screening effect and the effective nuclear charge are very closely related. Screening effect and effectively, definitely if the effective nuclear charge is very high, then the screening will be very high. That is correct. Screening effect of all the inner electrons is not equal. That is also true. S has highest, then P, then D, then F has least screening effect, right? Then we say the screening effect of D and F orbital is taken as almost constant here. Yes, that we have seen in screening effect in periodic classification, that why it is taken as almost constant. So answer is A is the correct answer here. Now let's see the next question. Choose the wrong statements out of these. First statement is, this is from environmental chemistry. Okay, and in environmental chemistry, I'll tell you that like if you just go through once the summary of environmental chemistry, you have time for that. Go through summary. Very easy questions are asked here. Very easy. Have you studied 9th and 10th class chemistry? Same kind of questions. Greenhouse effect they are asking based on that. So very easy, simple questions are asked from environmental and polymers. So I would advise environmental polymers, go through that. So CO2 is responsible for greenhouse effect. That is absolutely correct here. Acid rain contains mainly nitric acid. No, it also contains sulfuric acid. So this statement is false here. NO is more harmful than NO2. No, no, no. This is also false. NO2 is more harmful. Both are harmful, but NO2 is more harmful. It causes respiratory diseases as well, right? Then CO2 can absorb infrared. That is absolutely correct. Carbon dioxide absorbs infrared. That causes greenhouse effect, right? So we can say that statement 1 and 4 are true. They're asking wrong statement. That is second and third are wrong statements here. So answer will be A is the correct answer here, right? Okay. Yes. Okay, now next is, among the following complexes, the one that can exist as facial and meridional. Now this is from coordination chemistry, and I believe that easily there are top 3-4 examples of coordination chemistry isomerism they ask. There is only one example where we have facial and meridional, and that is Ma3B3, where facial is actually, if you say A and this is B together, and if here it is 1 2 3 4 5 6 and here it is A, then A, this is B and then B. This is facial and this is meridional isomer. This also they can ask you. See what related to, also I have told you what they can ask you. So this is geometrical isomer. Out of this is Ma3B3. So answer is A will be showing the geometrical isomers here. And also if you see it in 3D here, this is meridional, which is forming a semicircle. When it is on the same phase, let's say here, if I see here, not in the same phase, wait a minute, this will be in the same phase. Same phase means when they have same triangular phase, that is called as facial isomer. Okay, right? Okay. Someone is asking, ma'am, are you married? Why you are going to send me rishtas or what? Tell me. Okay. So which of the following, trust me, this question they will not ask you in VITEEE, is Diksha ma'am married or not? Question of 10 marks. No. This they will not ask you guys. So focus here. Right. Which of the following complex ion is expected to absorb visible light here? Which will absorb the visible light? See, It is just another way of asking. Question is same. Absorption of visible light means they should show color. Color means they should show DD transition. That means except for DD transition will be shown except for D0 and D10. So if you see this here, this is titanium, this is X plus 0 plus 0, that is X is equals to plus 4. So you can see this is titanium plus 4. Titanium is 4s2 3d2 subtive, that is 22 4s2 3d2. You take out all the electrons, it will become 3d0. That will be colorless because there is no DD transition here. What about this one? Here it is ammonia also is a neutral ligand, so it will be chromium 3 positive. Chromium is in the category of 4s1 3d5. Okay, half filled electronic configuration. You take out 3 electrons, 2 here, 1 here. It will become 3d3 here. That means 3d3, it will show DD transition. It will show DD transition, guys. So that means this is going to absorb visible light. Answer we got, that B is the answer. Now let's talk about others. Zinc 2 positive, bacha. Zinc is 4s2 3d10. You take out 2 electrons, it will become 3d10, no DD transition. Then scandium 3 positive is also, scandium is 4s2 3d1. You take out 3 electrons, it will become 3d0. Again, it is colorless. There is no DD transitions over here. So answer is going to be B is the correct answer here. Right? Okay. Yes. Yes. Okay. Now tell me next thing. Let's talk about the next question here and let's see if you can answer this or not. So this is a question that if you know, you can answer this within seconds, right? So this is the total number of metal-metal bond present in CO twice carbonyl 8. So CO twice carbonyl 8, how does it look like? Firstly, there is one cobalt bond. Then there are 3 carbonyls here, right? There are 3 carbonyls here, right? Then 3 or 4 carbonyls are there. Here you have 4 carbonyls here, right? 4 carbonyls here. Okay, I'll just draw it with a proper symmetry. 1, 2, 3, 4. 1, 2, 3, 4. Na. Oh, 3 only were there. Total 8 na. Huh. 3, 3, 3, 3, 3. Yes. Acha. 1 was bridge here. 1 was bridge here. So what you have here, you have, they can ask you also, you have 2 bridged ligand, you have 6 terminal ligand also they can ask you, 6 terminal ligand. Then there is 1 CO bond, that is answer will be D is the correct answer here, right? Okay, done. Okay, next question, let's see, let's talk about it. That is atomic number of manganese, iron and cobalt. Guys, don't spam, right? Those who are asking about bitsat, please don't spam, right? Okay, see, atomic number of manganese, iron, cobalt are these are the 3. We don't need that, bro. We are super smart, right? Which of the following inner orbital octahedral complex ions are diamagnetic? So for that you have to draw all these 4 ions here. So that I will be doing here with you. So you have 4 structures here. One is cobalt, ammonia, 6 cobalt. This is ammonia. This is 6 and this is overall 3 positive here, right? 3 positive. Tell me everyone. Then manganese, CN, manganese, iron, 3, 4, 3. Okay. Manganese, iron. This is iron, CN6, iron, CN6. Then charge is 3, 4, 3. So it is 3, it is 4, it is 3. Okay. Now one by one, let's do that. Okay. Let's do it fast. So x plus 0 is equals to plus 3. Cobalt plus 3. Cobalt is 4s2 3d7. 4s2 3d7 means 2 electrons from here, 1 from here. It will be 3d6. Right. This is x minus 6 is equals to minus 3. This will be manganese plus 3. Manganese is 4s2 3d5. You take out 3 electrons, 2 from here, 1 from here. It will become 3d4. Right. Then here x minus 6 minus 4, it is iron plus 2. Right. And this is iron plus 3. Now x minus 6 minus 3 is plus 3 only. Na? X minus 6 is equals to minus 3 is plus 3. So here it is 4s2 3d6. You take out 2 electrons, it will become 3d6 here. This is 4s2 3d6. You take out 3 electrons, it will become 3d5. Right. Now see, they are saying here, whenever ammonia is with cobalt in plus 3 oxidation state, it behaves as a strong field ligand. This is also strong field ligand. CN is always strong field ligand, right? So all of them are. That means pairing will always happen here. So here if I see 3d6, 1, 2, 3, 4, 5, 6, it is definitely diamagnetic. 1, 2, 3, 4, 5. 5 positions are there in D block, and you have 1, 2, 3, 4. This is also diamagnetic. Diamagnetic means no unpaired electrons. If you see this here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Diamagnetic only. What about this one? 1, 2, 3, 4, 5. It is 1, 2, 3, 4 and 5. This is paramagnetic here. Right? So here, wait a minute, have I done it right? Because the answer only 2 are diamagnetic. Inner orbital. Achha, they are also saying inner orbital here. Oh. Inner orbital is this one only. Diamagnetic, I can see 3 out of them. Right? So just give me a second. It is 2 plus 1, 3d6, right? This is also 5. So it will be 2 plus 1. This is 3d4, right? This also it is 3d6, 2 plus 1. You take out 3 electrons. It will be 6 only. No. Here you take out 2 electrons. Here it will be 3d6 only, right? Wait a minute. Mine answer is coming out to be 1, 2 and 3. Hai 1, 2 and 3. But there is no option like 1, 2 and 3. Wait a minute. Wait a minute. Have I done any mistake here? Wait a minute. Let me just see that, guys. Just give me a second. Have I done any mistake here? X minus 6 is equals to minus 3. It is plus 3 oxidation state. This is 4s2 3d5. In plus 3 oxidation state, it will be 3d4. Atomic number respectively following inner orbital octahedral complexes are diamagnetic. And why this one is paramagnetic? See, though I got it. Just give me a second. Acha. One thing though I didn't see only. I'm just looking at its diamagnetic character. See one thing here, guys. One minute thing. See. Here, if you have 6 orbitals, 6 empty you need. So what you need here? 1, 2, 3, 4. Wait a minute. So let me just draw it. Right. 1, 2, 3, 4, 5. So this will be D2 and this will be S and this will be P3. So I don't need to jump any electron here. Here it will be D2sp3, but because of this it will be paramagnetic with the D2sp3, right? This is going to be again D2sp3. But here if I want to have D2sp3 one electron will jump here. See, because it's a strong field ligand, firstly this will only happen. But after that, what you will see, that you need to make the octahedral complex here. For octahedral complex, you will use this part here. This is S and this is P3. So you will use D2sp3. That is why when you use D2sp3, one electron will jump from this position to this position, and that is why this will become paramagnetic, right? Okay. So I think they could have done this little bit tricky here by doing which thing? They could have done this little bit tricky by doing one thing here, that they would have given you 1, 2 and 3 as the options. Then there can be mistakes that could be done by students. So answer will be 1 and 3, that is C is the correct answer here. Okay, yes everybody? Okay. Now let's see in the context of lanthanoids, which are the following statements is not correct here. 14 elements in the 6th period that are filling 4F subshell. Yeah, there are 14 elements of lanthanoids in the 6 periods that are filling 4F subshell. That is why they are 4F. That is true. 58 to 71. Common oxidation state is +3. That is also true. Availability of 4F electrons results in the formation of compounds of +4 for all the members. No. This is for elements like cerium 4 positive, not for all the members. So that is incorrect, that it is for all the members, right? That is incorrect. So they are asking you not correct statement. So answer will be C here. See, a lot of questions like not correct, correct they are asking. There are general gradual decrease of falling elements with increasing atomic numbers in the series. That is correct. As atomic number increases, the size will decrease here. That is also true. Okay, next is which of the following lanthanoids are used in TV screens, and which lanthanoid is used here? Cerium is used in the TV. This is a factual question, right? Cerium is used in the TV screen here, right? Okay, cerium is used in our TV screens. Next is which of the following compounds is used as a starting material for preparation of potassium dichromate? Right, for formation of K2Cr2O7, you use it from chromite ore. And what is chromite ore, everybody? Chromite ore FeCr2O4. Answer C is the correct answer. That is the chromite ore, right? Okay. Okay. Yes. Now, next is which of the following oxide is diamagnetic? Which of the following oxide is diamagnetic in nature? See, if you see this, which of the yes, very good. So, which of the following oxide is diamagnetic in nature? See, if you talk about NO2, right? NO2 is paramagnetic only. It has one odd electron. But when two NO2 are connected, it forms N2O4. That is a dimer of NO2, which is actually diamagnetic, because two odd electrons have been connected. So that is why B is the diamagnetic compound, diamagnetic oxide here. The stability, yes, the question that you are saying, you can also do it by CFT, whichever you are comfortable in. Okay? Whichever if you do it by CFT, that will be even better. You do it by VBT, then you should be clear that when D2sp3 happens, we can't leave any empty orbital. You have to unpairing of the electron will happen. So original, this is from CFT only that you can answer this. That's why CFT theory was made here. But answer you can get from VBT only. That's totally your choice which you want to use, right? The stability of dihalides of silicon, germanium and tin. Ka si gaye Sant Prabhu, down the group. And they are asking about dihalides. That means +2 oxidation state, which increases down the group. Always lower oxidation state will increase down the group. Always and always. always guys lower oxidation state will increase down the group. Okay, so that is why here you will see that PB will have maximum stability, then tin. After PB it is tin, then germanium, then silicon. So answer will be B is the correct answer. Lower oxidation state of any group increases down the group, right? Okay. Yes, Anoop, Deepa, Sandhya, yes, Uma, very good. Okay, let's talk about the next one. Consider the following boron halides. So these are the boron halides and they are asking you the Lewis acid characters of these halides are in the order of what? What is the order of Lewis acid halides? Okay. So see one thing. This is boron and this is some halogen, right? So it is actually in trigonal planar geometry, right? If you see that boron has only 6 electrons, that is why it is electron deficient. So now one possibility is that the lone pair on halogen donates its electron to the boron. This is one possibility, right? This is one possibility. If lone pair on halogen will start donating to the boron, see what is Lewis acid? Lewis acid means what do you mean by Lewis acid? It means electron deficiency only. More is the electron deficiency on boron, more will be the Lewis acid character. And electron deficiency of boron will decrease if these lone pairs are easily available, right? That means this Lewis acid depends upon electron deficiency of boron, which is inversely proportional to the donating capacity of halogen. If the halogen is very good in donating, then what will happen? Boron will not be electron deficient, it will be a poor acid, right? So here what we have seen that in case of boron, it is 2p. This is also 2p, this is also 2p, this is also 2p. But fluorine, it is 2p, this is 3p, this is 4p, and this is 5p. That is why overlapping is maximum in case of BF3. That is why in case of fluorine, maximum donation happens. So BF3 is a poor acid because electron deficiency will decrease. So you can say BF3 is very poor and BI3 is very rich. So you can say very rich, very good acid, right? Very electron deficient. And BF3 is very less electron deficient, so it's a very good acid. So answer will, it's a very poor acid because it is not electron deficient. Electrons are being provided by this fluorine here, right? So answer will be A is the correct answer here. Next is, which of the following oxides of group 16 has the highest dipole moment? Such a simple question, right? Boiling point. Even simpler question. See, boiling point in case of usually what happens, right? Usually what will happen, this is H2, H2S, H2SC, H2P, right? Usually what should happen, this should increase, right? But what will happen, water due to its hydrogen bonding will have maximum boiling point. This is because of the hydrogen bond in water. That is why it should have least, but it will have maximum, right? Okay, next question. The structure of XCOF4 is what? See, how do you find the structure? First, you calculate the steric number. Steric number is Z is equals to half. Valence electrons, this is a sentimental atom, that is group number 18. So valence electrons are 8. Monovalent is 4, right? 4 fluorine are there, 4 monovalent. No positive negative charge, 8 plus this is 12 by 2, that is 6, right? That is sp3 d2 or d2sp3. You don't write the hybridization here, but you can still write it sp3d2. That will be octahedral. Geometry. I am writing just geometry. Okay, structure I have not written till now. How many lone pairs are there? Lone pair is what? Lone pair is valence electrons are 8. Out of that, xenon has one double bond with oxygen and 4 bonds with fluorine. That means 1, 2, 3, 4, 5, total 6 bonds it is forming. So it means 2 electrons are outside. That means 2 by 2, one lone pair will be there. So that means xenon has one lone pair and rest of it is the bond pairs. So this is nothing but it is square pyramidal. It is forming a square. This is forming a square, right? Okay. And this is one pyramidal. Square pyramidal. Square pyramidal. Okay. Answer is square pyramidal. So answer will be A is the correct answer here. Is that clear, everybody? Tell me. Right? Okay. Tell me, everybody. Done? Where you are saying that? Wait a minute. There is N2O5 as well. Then to N2O5 also will be the correct answer. I didn't see it only. Then this also will be the diamagnetic. This is also diamagnetic. So I think maybe there is some printing mistake here. Either it should be N2O maybe. I think it should be N2O, right? Okay. Because in the official answer key, the answer is this one. So N2O5 is diamagnetic only. That means it should be N2O. You're right. Okay. It should be N2O here. Right? Because N2O5 is also diamagnetic in nature. Okay, good, very good. Chalo, let's see. I want these kind of attentive students in my class, right? Awesome. Acha, PH3 has more lower boiling point than NH3 because lower boiling point. Again, it is same as water because NH3 is able to form hydrogen bonds. That is why its boiling point is higher. Right? Next question is orthosilicate ion is what? Orthosilicate ion, which it is this kind of ion. O negative, O negative, O negative, O negative. That means SiO4, 4 negative. So answer will be B is the correct answer here. Right? Okay. Right. Okay. Let's talk about those who are defining it difficult to understand any concept. I would advise you watch my one shots. That will help you. Right. Skip the unnecessary things and only jump to the concept part of my one shots. Right. That will help you. Okay. Which of the following option is correct regarding OF and F2? Okay. Now this is based in okay, more stable towards dissociation. See, this is based on MOT only. How many electrons are there? F2 has 9 to 18 electrons. This has 9 plus 8, 8 to 16, 17 electrons. Because of 17 here, this is having 1.5 bond order and this is having 1 bond order. So OF bond order is more as compared to F2. If bond order is high, see, bond order is directly proportional to bond dissociation enthalpy. It is inversely proportional to bond length. And it is also directly proportional to bond strength. Right? So here, if you can see if bond order is of this order, then bond dissociation enthalpy is also of this order. Right? So you can say OF is more stable towards dissociation. Yes, because its dissociation enthalpy is high. So this thing is true here. Paramagnetic character, if you see, this for this a very simple thing is whenever you have OP, just remember OP. For odd electrons, always it is paramagnetic, and diamagnetic will be for ED, right? Just remember OP, ED is opposite. For even, it is always diamagnetic. Exception is for 16 and 10, even though they are even. For even, it should be diamagnetic, but these are the exceptions. 16 and 10 are the exceptions, that even being even number, they will be paramagnetic, right? Just remember this particular part. So 17 means odd, odd means here, odd means paramagnetic, this will be para, and this means 18, that is even, that means it will be diamagnetic. So we can say OF is para, F2 is dia. So both the statements are correct. We can say both A and B are correct here, right? Okay. Acha. Now let's see next one. Let's see the next one, guys. Next is, you have 4 shapes you have to draw, like you have to equate. See, if I talk about NH4, you don't even need to draw it. It's quite simple. I'll just draw it here. NH4 positive. I'll just draw the Z also if you have no idea about it. Nitrogen belongs to group number 15. So 5 outermost electrons plus 4. And here you will subtract 1 electron because of positive charge. So 5, 6, 7, 8, 8 by 2 is 4. That is sp3. It is tetrahedral. So I can say this is tetrahedral, right? So D will be 1. D will be 1 and only in this is such a simple question. C is the correct answer. D is 1 only in one case. There is not even need to do anything here. But that is so weird, right? So I'll do it others for you as well. So if I talk about SF4, it is seesaw shape, but we'll see how. It should be like on your tips. If you've done enough practice, it is already on your tips. But let's see. If you see Z is equals to half, sulfur belongs to group number 16. So 6 outermost plus 4 is 10. 10 by 2 is 5, right? 5 means sp3d. That means trigonal bipyramidal. Lone pair are how many? So if you see, lone pair will be valence electrons is 6, and out of this 4 are occupied, divided by 2, that means 1 lone pair. So you can see sulfur is having 1 lone pair, right? And others, lone pair is always on the equatorial position in trigonal bipyramidal, and this is a seesaw shape, right? So answer will be seesaw shape. So answer will be this. Achha, what about HClO2? HClO2 is just like water. Like in water, you have H and H now. Instead of H, this will be Cl double bond O. This will be angular kind of shape. Okay, this will be angular shape, very famous shape. Then BrO3 negative. What about BrO3 negative? This is also quite simple only, but still I'll do it for you. Z is equals to half. Half is bromine is 7 and there is no monovalent. So it will be plus 0, plus 1 is for negative charge. This means 4, that means sp3. So it is going to be tetrahedral, and how? Br double bond, and this is double bond, right? Not lone pair here, right? BrO3. Wait a minute. This is 4 now. Yeah. 1, 2, 3, 4, 5, 6. Wait a minute. Let me see the lone pair here. Lone pair will be 7 outermost. Out of this, because with oxygen it is forming a double bond. So 6 bond pairs are there. So 7 minus 6 bond pairs. So that means you will have 1 here. So valence electron is 7 plus 1 is for this negative charge. And out of this 7 plus 1, you are subtracting 6 bond pairs. So it is going to be 8 minus 6, that is 2. 2 electrons means 1 lone pair. 1 lone pair means this is going to be Br, 1 lone pair, double bond O, and this will be double bond O, and you can draw it overall, it is negative here, right? Okay, understood. So you can see this here, it is going to be pyramidal shape. Why pyramidal shape? Tell me. Why pyramidal? Because in tetrahedral, when there is one lone pair, that is called as trigonal pyramidal or pyramidal shape, that is this one. See, we got the answer already, but I'm just telling you for the sake of telling that we have solved everything here, because otherwise students say, ma'am, you have crammed the solution, ma'am. Right? Trust me, there are students like that. Among the given species, the isostructural pairs. Isostructural means same structures. See, BF3 already you should know, right? BF3 is trigonal planar, right? This NF3 is having this kind of structure. Lone pair here, this is tetrahedral. So this is definitely not. BF4 negative. Okay. Let's see, we just need to find the hybridization here. So if you talk about this one, here it will be Z is equals to half, bromine is, there is no bromine, there is boron. Boron is hydrogen, helium, lithium, beryllium, boron. Boron is 13, it belongs to group number 13. So 3 outermost electron plus 4 plus 1. 4, 4, 8 by 2 is 4. That is sp3, right? So it is also going to be tetrahedral only. Yeah. So it is going to be isostructural, okay? This is going to be isostructural because Z is coming out to be 4 and there are 4 bond pairs in both the cases. So answer will be this, right? Because it is going to be BF4, 1, 2, 3, 4, and this is going to be negative overall. And here it is N, hydrogen, 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 positive overall. Here this positive is on nitrogen, negative is on this boron. Okay, that's how it is done. If you see, this is trigonal planar and this BrCl3 is very famous. If you see, Z is equals to half. We know the answer, but I am still doing it for you. Half, and bromine means 7 valence electron plus 3, 7, 8, 9, 10. 10 by 2 is 5. So it is, this is sp2 and this is sp3d2, sp3d. So definitely not, right? Because it will be having that kind of structure where you have 2 lone pairs and 3 are the bond pairs. So 2 lone pairs will be here and 2 lone pairs will be here. Okay, and it is going to be a T shape. Okay, this will be T shape. And this one will be again planar, trigonal planar. Okay, trigonal planar. What about this? This is tetrahedral. We all know how ammonia looks like, right? What about this one? This NO3, Z is going to be half. This is nitrogen is 5 outermost and there is plus 1 electron. So 6 by 2, that is 3. So it is actually sp3. Okay, so nitrogen with a double bond, and with oxygen negative. Okay, sp2 hybridization, trigonal planar again. Okay, got it? Tell me yes. Okay, chalo. Now let's see the next part here. Next question, that is, which of the following statement is correct? Statements are sp3 hybrid orbitals have equal s and p character. Definitely not. It is by 100, so it will be 25% and this will be 75%. So that is not correct. Bond angle decreases with decrease in S character. Definitely yes. Sp has maximum, then sp2, then sp3. This is the relation of bond. This is the relation of bond angle as well, because here the bond angle is 180, here it is 120, and here it is some 109 degrees. So bond angle is decreasing, S character is also decreasing. So this is true. Resonance decreases the stability, not at all, it increases. Resonance is due to sigma electron delocalization, not at all, it is due to pi electrons delocalization. So answer is B is the correct answer. Next question is, which is largest in size in aqueous solution? Now see, lithium, sodium, potassium, rubidium, cesium, right? Down the group size increases, right? The size of the ion will increase, so I can say it like this: lithium, okay, size is increasing. If size is increasing, they are asking about the size in aqueous solution. So see, if a smaller atom, see, let's say there is a smaller atom, there is a bigger atom. Smaller atom will have more hydrated molecules around itself as compared to larger atom, right? That is why smaller atom, because of more hydrated molecules around it, it will have more size as compared to larger. So we can say hydrated will have opposite. Lithium aqueous is going to be, because its size is very small, so this is going to be maximum. Then sodium aqueous, then potassium aqueous, then rubidium aqueous, then there is cesium aqueous. So answer will be, largest will be lithium here, right? Okay. Oof. Next is arrange the following in order of their electronegativity, right? Okay. Sometimes I want to ignore, but sometimes I want to answer. You're asking me about my skin tips. So there is one skin tip that I would advise you. Hard work. Yes. Now do that. Okay. Which of the following in order of their electronegativity? So if you see electronegativity, this is carbon, nitrogen, this is oxygen, this is fluorine. So electronegativity will be of this order. Fluorine has maximum, then oxygen, then nitrogen, then carbon. Answer is going to be D is the correct answer here. Right? Okay. Chalo. Now let's see. How does electron affinity change when we move from left to right in a period? Such a simple question. Left to right when we move. How electronegativity or electron affinity? Size decreases, electron affinity in general increases here. When we go left to right, size will decrease. Electron negativity will increase. Electron affinity will increase. Ionization enthalpy will increase. Non-metallic character will increase. Right? All these things will increase. Right? So answer will be A. Last question. Which of the following statement is not correct? Ionization energy increases on going down a group. Among alkaline earth metals, reducing character, so they are saying not correct. Ionization enthalpy increases on going down a group. Ionization enthalpy, guys, it is increasing along a period. Down the group, it is decreasing. Okay, so this itself is a wrong one. So not correct is this one only. Answer is A. Among alkaline earth metals, reducing character increases. Alkaline earth metal means group number 2. Reducing character increases down the group, that is correct. Reducing character will increase down the group, that is absolutely correct. Fluorine is most electron, that is also correct. Metallic character increases on going down the group, yes, it is increase. Non-metallic character is increasing along the period, down the group it is decreasing, so that is also, sorry, non-metallic character is increasing along the period, down the group non-metallic is increasing, non-metallic is decreasing, and metallic is increasing, that is also correct. So answer will be A is the correct answer here. Okay, right? Okay, tell me everybody. Yes. Tell me everyone, is that clear, all of you? Do let me know in the chat box, is that clear or not? Tell me. Done. Okay. So that was about top 30 questions, and I have not picked 2025 questions on purpose because I am thinking of doing like a separate paper of 2025. Like I want to do it together. Like one day I'll take 2025 paper together. Physical, inorganic, organic, mixed, whatsoever was there in 2025. Right? Okay. So right now I'm doing just that warm up sessions here so that you can be ready for that mock test of chemistry here. Right? Okay. Yes. Okay then guys, I hope so you have liked the video as well because so many efforts I'm putting just for you guys, right? And also stay connected because today there will be a video that is I think also is live right now. Let me just see if it is live or not. Let me just see that. Mm, wait a minute. Let me just see because after full analysis of your JEE, those students who are preparing for JEE, so yeah, this video is live here. You will see it's a 40 minutes video. You can watch it on 2x speed here. I'll just show you this here as well, right? Mm. Don't worry, I'll do. Firstly, let me complete physical and inorganic organic chemistry. Right, let me complete that as well. So we'll do that. Don't worry. Right. See if you see this here on this channel. Go to video section, right? And what you will find here, you will find this. Okay. Okay, on the video sections, you will find this, right? So on the video section, you will find this. Click on this video and let's ignore ads here, right? Okay, Diksha doesn't have premium, guys. Okay. So if you see this here, right, this is the full data, right, of your 2026 what you need to, like, which colleges you can go for if you have this much score, right? For example, you have 181 marks, then which colleges, and about that college's admission counseling process, its rank percentile needed, and its average package. So everything you have here, and you have an option without premium also. You have an option of this 2x speed here. Just go to 2x speed here. If you have premium, you can also watch me at 3x speed, but that you will not understand anything, right? So watch it at 2x speed so that this becomes a 20 minutes video for you. I cannot speak at 2x, but you can obviously listen to this at 2x speed, right? So go through this because this is a very, very important videos, right? So all these things are quite important for all the students who have also prepared for JEE, right? And right now they are thinking that which college they should get into, right? Everyone clear? Okay, wait a minute. Let me just see you guys here. Yes. Okay. Can I see you guys? Yes. Okay. Okay then everybody. Yes, to get into VITEEE Chennai. Yes. We'll talk about that, right? Firstly, prepare. I'll make a proper. I have already done a proper video on all about VITEEE EEE. You can go, everything, rank and all, everything is mentioned there, right? Okay. Yes. Okay then guys. Bye. Take care. See you all in the next class. That will be for, first thing is, all the students who are preparing for BITSAT, or even if you're not preparing for BITSAT, this is for all the students. Tomorrow I'll be taking a session of English and reasoning in the morning class, right? So that can also be beneficial for all my VITEEE EEE aspirants out there. So you can watch that as well, right? Okay. Yes.